Good morning, guys. So we're back with another lead code question. That's today's daily challenge. So today's question is the house robber, one of the most famous questions in lead code. Let's get to the statement here. Statement says you are given a professional. Oh, sorry. You are a professional robber planning to rob house along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security system connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer nums representing the amount of money of each house, return the maximum amount of money you can rob tonight without alerting the police. So yeah, looking at this, it looks like a recursion question to me. There are multiple ways of solving this question, but we are going to solve it using recursion and dynamic programming. So yeah, so let's assume that you are the robber and these are the houses, right? These are the houses, okay? These are the houses. So if I'm standing here, so I have two options: either to rob the first house or to leave the first house and move to the second house. I have only two options, right? Either I rob this house and jump to the this house, second or third house, or I don't rob this house and jump to this house. So I have two options here. Okay, I should hold on. I'll make a more clear diagram. That I have one option or I have second option, and then I'll decide here what I'm going to do. So I have only two options, right? So that's what we are going to make a function for. We are going to make a recursion function which we will perform two operations. One will be that we are going to leave the house and move to the next house, like this one, A or B. We will rob the house, the first house, and then we'll jump to the third house. And similarly, here we'll perform two operations. Either we'll rob this house and jump to the second house from one, leaving one house from this position, or we'll will not rob this house and we'll jump to this position like this. Okay, so yeah, these are the two options we are having here. So let's jump to the code quickly. So we'll write a recursion function here. Let's name the function rob, and the arguments we are going to be passing here are nums and I. So I here is the current index, that means the current position. Initially it will be 0, and here we are going to have two options. Option A is that we don't rob the house and we leave the house, we jump to the next house. So we didn't rob the house, we just jumped one, we jump to the next house. Okay, or B, we do rob the house and then we jump to the third house, that means I plus 2. We are taking two steps, we're jumping, we are skipping one house and we are jumping such that the security system is not alerted. Okay, so in this case in which we are robbing the house, we're gonna be adding the value of the money in the first house, because we have robbed the first house, so we have to add the amount we have robbed here. That is going to be I, nums I. And we are going to write an end case here. If I is equals to that means we have reached the end. In this case we have surpassed the end, that means we have to return 0 here. And if we have reached the end, that means we are at the last position, then we'll return nums of I. I think we don't need this condition, but anyways, I think it's better if we keep it. It's not a harm. We'll check at the end if we really need it or not. And what are we going to return? So we are going to return the maximum out of these two cases. Did this step in the future give me the maximum, or this decision may give me the maximum? So we have to check it here. So let's answer b equals to max a b. In the future we don't know that which of these a and b is going to give us the maximum value. It can be any of these two, so we have to check it here, and whatever is the maximum we will be returning here. Just have to write return rob 0, because we are starting from 0, right? So let's try and run this. So encounter a error here because it's just a syntax error. Let's see if we get any more errors. So as you can see, these two test cases are passing. At least these two test cases are passing. Let's try to submit it. And I think we are going to get a time limit exceeded error, because our time complexity is in somewhat 2 to the power 100. So that is huge number. As you can see, we have encountered the time limit exceeded error. So now we are going to use dynamic programming. So here, just to explain you guys, if I am at position 1 or position 0, I have two decisions to make, right? Either I rob the house, and either I don't rob the house, skip the house, the first statement A. Okay, I just skip this house and jump to the next one. So I jump to position I plus 1, I that is 1. Okay, because 0 plus 1 is 1. And or I rob this house and jump to position I plus 2, that is position 3, sorry, position 2. Okay, and either these two cases, we have these two cases, right? We are doing these two, but we are adding num I 0 here, right? And similarly here also we are going to be having two cases. Either we jump to second position or we jump to the third position, adding num 1. The same way we are going to create another another branches here. So here we are going to jump to the third position, or we are going to jump to the fourth position plus num 2. Okay, so here you will see that this branch and this branch exactly same, right? And they are going to return exactly same values, so we don't need to calculate them multiple times. So to prevent us from doing that and to save our time, we are going to memorize the answer of this one or this one, whichever we operate first. And when we have to decide, when we have at the position where we have to calculate it again, we'll just check our memo dictionary, that if we have the solution already present in the dictionary, we'll simply return it directly without going through all these operations. We'll just return it using our dictionary. So that's what we'll do here. We'll use a memoization. Memo is nothing but just a dictionary which has key value pairs. Memo here, and we also have to pass it in these two and here as well. Now if I is already in memo, okay, then we'll just return memo of I, and here we have to store the values. As we know now the answer for the ith query, we can store it in our dictionary equals to answer. Okay, I think we're pretty much done here. Let's try to run it. You can see that these two test cases are passing successfully. Now let's try to submit it. Yeah, a successful submission. Let me get rid of this for you guys. Okay, thank you for watching.